Now we'll discuss resistivity. To understand resistivity, student, just assume that there is two roads, national highway also you can say, and one is moving from Kashmir to Kanyakumari and another is from Bombay to Pune. So here the length is different but their width, suppose it is same, width is same and length is different. So in this case students should just assume in which case there will be more traffic. Definitely the road which is longer will have more traffic, and the road where it is short, only short distance will have to cover. So here that is traffic will be less. In the same way, we know traffic also opposes the movement of the vehicles in the same way as resistance opposes the flow or movement of current. So here we can say the resistance is directly proportional to length. That means if resistance will increase, if the length will increase, then the resistance will also increase. If length will decrease, resistance will also decrease. So resistance is directly proportional to length of the conductor. And this one we can say this is equation 1. And now come to another point, that is in the same way, suppose there are two routes, both is from Bombay to Pune, both are going. So from Bombay to Pune, that means their length is same but width is different. So if one that is the road where the width is less and another road where the width is more, so definitely in case of less width there will be more traffic, and where there is the road is broad, so the traffic will be less. The vehicles can move easily where the road is broader. So here from this it is the same as resistance also, that is opposition to the current, also vary in the same way. That means it area of cross section, that means it is inversely proportional to the area of cross section. That means if the area of cross section is less, the resistance will be more. If the area of cross section is more, the resistance will be less. So now from both the equation, combining both the equation, we can write this as resistance is proportional to length and inversely proportional to area of cross section. So students, see, if this is the relation, that is proportionality relation, but if we want to replace this proportionality constant, this proportionality to obtain an equation, what we'll have to do, in place of this proportionality we'll have to take a proportionality constant. And this student, this here if we are making resistance is equal to, then we'll have to remove this proportionality by using a proportionality constant, and this proportionality constant is said as rho. So rho into L by A, that is length of the conductor by area of cross section of the conductor. So this proportionality constant is known as resistivity of the material. This is known as resistivity of the material. So now from this equation we have come to one conclusion that resistance not only depends on the length of the conductor, or not only depend on the area of cross section of the conductor, but it also depends on one third factor, and that third factor is the nature of material of the conductor. and that nature of material of the conductor, that factor is said by resistivity. And resistivity here, the from this one we can find, suppose if we'll write this equation in this way, so we can write, sorry, rho is equal to R into A by L, and here L, if we want to derive its SI unit, so from this formula we can derive its SI unit, and its SI unit will become like, see, it is resistance, that is its unit is ohm, and area of cross section, that is meter square, and by L, the unit of L is meter. So here if we cancel it out, we will find ohm meter. The SI unit of resistivity is equal to ohm meter. And this, here one question arises, that what are the differences between resistance and resistivity? That resistance, what are the differences between resistance and resistivity? So here we can say resistance, actually it is the ability of conductor to oppose current, but resistivity, it is the ability of material of the conductor to oppose current. So here from this one, that means the resistance, it depends on length of the conductor. It also depends on area of cross section of the conductor, and it also depends on the nature of material. Material. Now here this one rho, it only depends on, it does not depend on length and area of the cross section, and it depends on the material, which type of material has been taken. So for example, silver, suppose we want to conduct electricity, properly, so in max optimum amount, so in that case we can use silver is used in that case. So why? Because the opposing property of silver is very less. So silver, that is here resistivity of silver is very less. This resistivity also can, this one numerically also can be defined as the resistivity of a substance is numerically equal to the resistance of a rod of that substance, which is 1 meter long and 1 square meter in cross section. For example, by suppose say we are telling that the resistivity of copper is 1 point. Suppose the resistivity of copper is 1.69 into 10 to the power minus 8, and its unit is ohm meter. So now by saying this, the resistivity of copper is 1.69 into 10 to the power minus 8 ohm meter. We mean that if we take a rod of copper metal 1 meter long and 1 square meter in area of cross section, then its resistance will be 1.69 into 10 to the power minus 8 ohms. And the resistivity of alloys are much more higher than those of the pure metals. from which they are made. For example, the resistivity of manganese, which is an alloy of copper, manganese and nickel, is about 25 times more than that of copper. And the resistivity of constant tin, which is an alloy of copper and nickel, is about 30 times more than that of copper metal. So another alloy having a high resistivity is nichrome. So next time we will discuss, student, another topic, and thank you for listening this one. Stay home, stay safe.